Welcome back to the exciting conclusion of Matter Phases and Changes, Part 2. So you should be okay with this. That was the Part 1. And now we're going to kind of get into Part 2. But just something that I did want to show you is maybe this will help to kind of think about some stuff. If we say, here's our three main matter phases, right? And we know that if we've got solids, liquids, or gases, how we're going to describe volume and shape for those. And you should be getting kind of familiar with if I go from a solid to a gas, or a liquid to a solid, or a solid to a gas, or gas to solid. What do we call those as far as like what's the terminology? Evaporation, condensation, evaporation, sublimation. We should kind of be at a spot where we could work through what each of those does. And did it require energy to go into that system, endothermic, or kick out of that substance, exothermic? So something else I wanted you to kind of think of is way back that matter phases demo with a little jar that I had and kind of shaking up those little clay balls. We had our solids where everything was pretty tightly packed, right? And then in that example, I took some out, but you notice that as I went from what was supposed to be a solid to a liquid, all of a sudden these particles, they could kind of flow, right? I mean, they could make their way past each other, and rather than just shaking in place, there was actually kind of some movement past each other. So in order to go from just shaking in place to kind of some moving past each other, a little bit faster movement, as we go from this way to that way, if we're getting faster movement, we got to get energy into it, right? I mean, if I said, hey, I want something to move faster, do I have to put energy into it or pull energy out? Energy's got to go into it. So these would be endothermic, or your speed is going up and up and up. You're adding more and more energy. And then eventually, if I get to a gas, man, these particles, they're really moving fast and free. And that's why there's no set shape, no set volume. They're just whizzing past each other here, right? So then the other side of this is if I'm going down in a phase change from a gas to a liquid, or a liquid to a solid, or a gas to a solid, I got to have energy get kicked out of that. So it's going to be exothermic. So a way that you can kind of show all this is if you think from like top to bottom, my slowest is solid, liquid, gas, right? So really what we're saying here is faster, 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 or slower, slower, slower. And then you were to say, okay, well, if I want something to go faster, faster, I got to put some energy into it. That'd be endo. Or if I want something to go slower, slower, I got to get some energy out of it. It's got to kick energy out. That'd be exothermic. I think sometimes just like jotting this little diagram, picture, sketch, whatever, makes things a little bit easier. So you're not thinking mentally, okay, well, particles are moving faster. Why would that happen? What's the terminology for it? We went from this to this. And maybe this will be just a nice way to keep things smoother for you. If this is confusing you more than it's helping, then disregard. But just sometimes I think this is nice for kids. So to wrap this up here, we got to answer what phases occurred. And I just gave you some like real world scenarios here. So we're in the end of September when this video is being made. Just actually this weekend, we had some frost warnings, which meant there was going to be some frost that formed a little bit early, but nonetheless, I think we've all experienced frost either when you go out and there's like crystals, ice, snow, whatever you want to call it, on the grass or maybe on a windshield of a vehicle. So if that frost occurs, what had happened was you had the water vapor freeze. So think about that. Water vapor is a gas. It froze solid. So if you went from a gas to a solid, that's referred to as deposition. Your cold soda has water on the glass. All right. Well, if you've got water on the outside of a glass, that water vapor turned into a liquid. That's a good example of condensation. Ice cubes in the freezer have disappeared. So this might be something I know most people have, kind of like you press your cup against a little lever on the outside and the ice cubes just fall out magically. But back in the olden days, you had to make kind of your own little ice cubes and little ice cube trays. And if you left them in there too long, they'd get smaller and smaller and smaller. So you'd have a solid that actually just turned into a gas. And that process is referred to as sublimation. And deposition, sublimation, oftentimes those are two vocab terms that are tricky for kids. The way I always kept it straight when I was a youngster was sublimation starts with an S. So this is when I go from a solid to a gas. And then by default, I was like, oh, all right, well, deposition must be the other. A cup of water left out over the weekend is empty. So we went from a liquid to it's just disappeared. No, of course it didn't, right? I mean, matter can't be created or destroyed, but if I don't see it, that means that it turned into a gas. So if I went from a liquid to a gas, that's referred to as evaporation. Can of soda explodes in the deep freeze. Well, you've got liquid that became solid, liquid to solid. We call a liquid to a solid freezing. We've got my kids in the next room screaming at me. Yes, hello, Elijah. Not now, I'm working, buddy. Your slushies become a liquid. So you had a solid that became a liquid. So if we got a solid and it became a liquid, we're all familiar with that, right? That's just called melt. Or if you put melting, that'd be okay. So this is just like some real world examples to get your little brains thinking about what's what. And this guy here, this little diagram, this can kind of like pull everything together, but it can get a little bit tricky. So this is how I'm going to do it. And in my lecture slides, I had a picture that sort of showed you this. But if I go from here to here, or here to here, right? So there's my liquid. I know water vapor is my gas. So if I go from a liquid to a gas, that's going to be evaporation. And if I go from a gas to a liquid, if I go from a gas to a liquid, that's condensation. And now I can kind of use my little flow chart to speed up some of this stuff, right? If I go from a liquid to a gas, in my mind I'm thinking, all right, well, I got to get those particles to move faster. If I want it to go faster, I've got to get some energy into it. So if I go from a liquid to a gas, that's going to be endo. If I go from a gas to a liquid, I got to slow that down. So gas to a liquid, if I slow it down, I got to kick energy out. Oh yeah, that was exo. Hopefully that's kind of making some sense. If we take this guy here and solid water, so this is our solids, right? If I go from a gas to a solid, or a solid to a gas, remember I was telling you solid to a gas, oh, that's that weird one. That would be sublimation. And then this one here, like the frost forming, that would be deposition. So if I go from a gas, fast, to a solid, slow, I want it to slow down. It's going to have to lose energy. I'm pretty sure that'd be exo. Let's see here. Gas to a solid, I went down. It's exo. By default, this guy's got to be endo, right? I need to speed something up. And if I go from a solid to a gas, I got to speed that up quite a bit. It's going to take some energy going into that system. Here, we've got ones that most of us are familiar with even before this class, right? A liquid to a solid, freeze. Put freezing, awesome. Solid to a liquid, melt. Okay, liquid to a solid, kind of fast, slow. I'm trying to slow it down. I'd have to kick some energy out. I'm pretty sure if I'm kicking energy out, that's exo. Liquid to a solid. I went down, exo. So liquid to a solid, exo. I want to warm something up to melt it. I got to get some energy into that. That would be endo. Let's see if I was right. Solid to a liquid. Solid to a liquid. I had to like climb this little ladder. I'm going up, endo, energy into it. So I did not include plasma here, but let's just for funsies put it up over here. And there are other phases of matter, but this is really all we deal with. If you go from a gas to a plasma or a plasma to a gas, so plasma, remember we're defining that as an ionized gas. In other words, it's a gas that's moving so fast and so quickly that it's actually even losing electrons. So that's called ionization. And we haven't had a chance to really talk much about ions yet, but we will. So if I'm going from a gas to really speeding it up, you think that we're putting energy into it or pulling energy out. So think about all these trends here, right? If we're going faster, faster, like plasma would be up here, even faster, that's going to have to be endo. And then the term when you lose ionization to go to a gas, it's referred to as deionization. And then obviously that's got to be exo. It would kick some energy out. So hopefully that makes a little bit more sense. If you've got questions, concerns, as always, feel free to touch base. Until we meet again, bye-bye.